Hey guys, it's Cam from EasyA. This video is going to be on linear and simultaneous equations. So let's get started.
A linear equation is an equation where there are no powers of the unknown variables. Let's solve this linear equation. In order to solve it, the right-hand side of the equation must be equal to 2, as that's the value of the left-hand side. We can use inverse operations to solve the equation. Let's start by subtracting 26 from both sides of the equation. Then divide through by 8. This gives us the solution, which is x is equal to 3. We can check this solution by substituting it back into the original equation. Now, for a more complicated example, where there's an unknown variable on both sides of the equation. To solve this, we have to bring all of the unknown terms onto one side and leave the numbers on the other side. First, expand out the brackets and then use inverse operations to rearrange. I've collected the variables on the right and the numbers on the left. This gives us the solution, which is x equals 5 over 2. We can also solve this equation graphically. Split the equation up into two equations by taking the left and right hand side of the equal sign. We can plot these as lines on a graph, and where they intersect is the solution of the equation. We can see that it's correct, as we get the same value as before. Now, onto simultaneous equations, which are equations with more than one unknown variable. We need multiple of these equations in order to solve them. To solve, let's subtract equation 2 from equation 1, which will eliminate the y terms. To subtract one from the other, just subtract each term in the equations individually. This solves the equation and gives us an x value of 3. We then need to substitute it back into one of the equations in order to find out the value for y. We can use either equation. Let's check our answer with the other equation. If we substitute into this equation as well, our answer should also work. Sometimes you'll need to multiply the equations before subtracting or adding them from each other. In this case, we need to multiply equation 1 by 2. I'll call this equation 3. We can then add this to equation 2 in order to cancel out the x terms. Once we've done this, we'll get a value for y. We can then substitute this into any equation. I'll choose equation 1 because this is the simplest one, and this gives us a value for x. We can also solve simultaneous equations graphically. We can think of the solution as a coordinate, which lies on the lines of both equations. Plotting the lines and finding the point gives the same answer as before. At higher level, you'll need to be able to solve simultaneous equations when one of them is a quadratic equation. To do this, first eliminate the variable that isn't squared. This will give us a quadratic equation which we can solve to find the values of x. Then, substituting back into equation 2 gives two y values. Each x value has a corresponding y value, and they can't be mixed up. We can see that there's two pairs of solutions, and we can check both of these by substituting back into either equation.
Thank you for watching this EasyA Maths recap video. Check out our YouTube channel for more maths recaps, or get the EasyA app on the Apple and Android app stores to get unlimited on-demand maths tutoring right from your smartphone.